Hello everybody, this is DoubleChain Research Lab. Welcome to the world of homomorphic encryption. What is homomorphic encryption? It is an encryption scheme that can perform arithmetic operations on encrypted data. For example, suppose we have messages 3 and 7. Encrypt them to get E3 and E7. A homomorphic encryption scheme can add E3 and E7. If we decrypt this result, we will get 10, which is equal to 3 plus 7. Similarly, we can multiply E3 and E7. If we decrypt the result, we will get 21, which is equal to 3 times 7. Therefore, a homomorphic encryption scheme can support arithmetic operations. Thanks to these characteristics, homomorphic encryption schemes can protect our private information while we are making important transactions. In the financial field, homomorphic encryption scheme can be applied to detect abnormal transactions and evaluate personal credit information. These days, it is regarded as groundbreaking technology for big data analysis and artificial intelligence. So far, all the known homomorphic encryption schemes are based on the hardness of lattice problems or approximate GCD problems. So, it is expected that homomorphic encryption scheme can provide a safe crypto system against quantum attacks. Then, why do we need homomorphic encryption scheme? Consider the following situation. Suppose Alice has good data, but does not know how to handle this data. On the other hand, suppose Bob does not have good data, but he knows how to handle this data. So Alice sends the data to Bob, asking for help. But in this case, someone like Trudy, who is an evil, can intercept the data and can do every evil thing because he is an evil. To avoid this danger, Alice sends the data in encrypted form. Then Bob decrypts this data, performs necessary operations, encrypts the result, and sends them back to Alice. Now Alice decrypts the result and obtains what she wants. In the whole process, Trudy can intercept the messages, but cannot do anything because the messages are encrypted. But what if Bob is Trudy, disguising himself as Bob? Then he can do every evil thing because he is an evil. This is where homomorphic encryption scheme comes into the picture. In this case, Alice homomorphically encrypts the data and sends that to Bob. Bob performs arithmetic operations on encrypted data, but he does not know what are inside. Bob returns the result to Alice. Alice decrypts them and gets what she wants. In the whole process, Bob performs all the operations, but does not know what's going on because all the messages are homomorphically encrypted. This is how homomorphic encryption works to protect our private information. Now, let me briefly talk about DoubleChain encryption scheme. First, our encryption scheme is fully homomorphic. That is, we can perform arithmetic operations on ciphertext as many times as possible. Second, our scheme can deal with arbitrarily large messages. Third, our scheme can evaluate high-degree polynomials very fast. For example, if f is a 10,000-degree polynomial with 1 billion terms, and q is 100-digit prime number, we can evaluate f within just a second. And we can do more. Now, what are their applications? First, startup companies. They can store their new developments using our encryption scheme and make necessary transactions with encrypted data. Second, large companies. Even though they have very big R&D departments, they cannot do everything. They can use DoubleChain encryption scheme whenever they need to make our searching work, especially when they need our help. Third, banks, hospitals, schools, and other educational institutions. They need to protect private information of client, patient, students, etc. Actually, this was the beginning of homomorphic encryption schemes. Fourth, other industries and individuals. Thank you very much. If you like this video, please say so and subscribe our channel. See you next time.